Okay, well, here is another math problem, the last one, and again, might look a tiny bit intimidating, but it's actually one of the easiest ones so far we've gone into. So it says the nearest galaxy to our own is about 2 million light years away. So we have a distance there, and basically we want to take that distance, how many meters is that, and convert it from light years to meters. So again, we'll probably be using dimensional analysis, but I want to go ahead and show the easy way first of a simple multiplication problem. So let's use an easier example for now, like from yards to feet or something. So let's say we have point A and we have point B, and we have a distance between them, and we're going to have 1, 2, and that is my phone ringing, but I will ignore it. Actually, it's from my job, and I will ignore it. And, okay, 3, 4, 5, 6, 7, 8, and let's just make that 9. So we have 9 yards here, and what we want to do is we want to convert from this bigger figure, yards, into feet. So basically how you understand that is you understand that there are 3 mini segments in here. It's 1, 2, and that would be the third mini segment of basically feet that it contains. It's 1, 2, and this would be the third foot that it contains when you look at the space there. So essentially the way to find how many, if you have 9 yards here, you simply, it's very common just to multiply by 3 feet, which is the common factor, and you get the total amount of feet out of this, which was 9, 18, 27 feet total. And the way that works, if you want to look at the mathematics as to how that works, is that 9 yards, well, 9 times 3 is the same thing as 1 plus 1 plus 1, a total of 9 times here, total 9 times, and you have the 3 on the outside, and you're familiar with this because this is distributive property. So it's going to multiply that and that and that. So you see, mathematically, in this distributive property, it's the same thing as adding 3 segments here to each yard space, and that's how it works basically, just in case you didn't know. But generally we don't even need to know that in order to do this math problem. So in the end we get 27 total feet out of yards. So we have this same scenario here, and I'm not going to draw a line segment but just part of it. So this is going to be 1 light year, 2 light years, 3 light years, 4 light years, and out of this light year there are going to be segments in here, and now I'm drawing randomly because I really don't know how many are in there, of AUs, I mean of meters. Oh, actually, if we're dealing with meters, it's going to be this line might as well turn blue. There are going to be so many segments in that. So the way we do it is simply by multiplying. So 2 million, and 2 million is the same, if you remember from scientific notation, is the same as 2.0 times 10 to the power of 6, because we're counting the 6 zeros here. Alright, so 2.0 times 10 to the power of 6 is going to go ahead and be multiplied by this factor right here. So 9.5 times 10 to the power of 12 is kilometers. You plus 3 to the amount of zeros to get the meters in the powers. You'll notice that's where the difference is. So 9.5 times 10 to the power of 15. You multiply those together, and again, it's, if we had a 9.5 times 10 to the power of 15 over here, it will be adding all those segments to each light year, and that's how it works mathematically. So when I shove that in my calculator, 2 million times 9.5, I end up getting 1.9, and what comes out of the calculator is E22, which is the same thing as times 10 to the 22nd power. Alright, so there is the answer.